Welcome to our live webinar on making optimal use of smart field devices. Thank you for joining us. Today's webinar is co-hosted by Automation.com and Softing Industrial. My name is Renee Bassett, and I am Chief Editor of Automation.com. I'll be your moderator for today. At the end of the presentation, I will ask our presenter to answer as many questions as time allows while keeping to the overall presentation time of 1 hour. If we run out of time, all questions will be forwarded to the presenter for response via email. Note that this presentation also includes live polls, which will pop up on your screen for your input. Poll results will then be shown in real time. Lastly, at the end of the presentation, you will be prompted to take a brief survey. We appreciate your taking the time to give us feedback about your experience today. Now, about today's presentation. Smart field devices provide plant operators with important information on plant status. This data forms the basis for planning preventive maintenance work and other tasks. An interconnected suite of mobile device interfaces and professional applications can enable technicians to monitor and control processes on site and in detail. In this webinar, you will learn how mobile solutions help you get the most out of your smart field devices, how plant availability can be ensured through correct device configuration, and the advantages of a tablet plus interface solution over a conventional handheld communicator. Today's presenter is Skelly Shala from Softing Industrial, and he will also discuss use cases for Softing's mobiLink solution. So, without further delay, here's Skelly Shala.
So, hi everybody, and thank you Renee for the nice intro. A warm herzliches Willkommen from Germany from my side here. So yeah, Softing Industrial is a German-based company. I'm a product manager since 2018 with Softing. Today we're going to talk about making the optimal use of your smart field devices and about asset management. Here my agenda. We will start with a short intro. Then I will tell you something about mobile plant asset management. Then we will talk about device communicators and different kind of device communicators. And then we will proceed with the solution from Softing, the mobiLink. So, intro about Softing. As I mentioned, Softing is a German-based company. We have 3 business units, and all of these 3 business units are focusing on connectivity in those markets. We have an automotive business unit. They are focused on solution for ECU diagnostics. So ECU are all the electronical control units inside of a vehicle. There are over 100 control units inside of every vehicle. We build up there the connection between all these communication units, control units to any applications that need those data. Then we have IT networks as a business unit. They are qualified in measuring equipment to test, qualify, and certify copper and fiber optic wiring of IT systems, mainly in buildings and in office areas, but also in industrial areas. Then about my business unit, the industrial part. So we have products and technology for network industrial production. So by meaning said, okay, we have products and technology. So we are also we have a lot of know-how about different types of technology. So even companies come across us and ask us for consulting or any technology integration projects they have. That's about Softing. I'm not going into deeper with that. About me, this is a picture of me. I'm, as I mentioned, a product manager at Softing since 2018, and I'm a mechatronics engineering, and I have also a degree in innovation and technology management. As a product manager here at Softing, I'm responsible for variety of products here at Softing, and mainly about interfaces. They can be mobile or stationary as there are in gateways. So to start everything here, I would like to show you guys the steps of knowledge by AJ North. He has defined a way where, or a pretty nice and easy module where we come from models to benefit. And this is like the main goal of every company to get benefit. And the steps of knowledge explain how we get from symbols. Symbols can be any kind of process values or any values, and from those values we make data. Those data are the connection between symbols and data is if I only have any process value saying like, okay, 21 is a value, but I don't know what it is. Is it 21 Fahrenheit? Is it 21 Celsius? Is it 21 liters? And if I have context to those values, I have data. And if I add those data with another information of, okay, what it is it liquid, how much liquid is it, it turns to information. Out of information, I can generate knowledge. Out of knowledge, I can react because I know, okay, this shouldn't be that way, it should be that way. So we can react. If we react, we always react in a way that we optimize things. And of course, if we optimize things, we directly generate benefits. And this is like the steps of knowledge where we start from symbols, from simple information that we don't know what it is exactly, and bring it to benefit. So the first part of this is it's an information management where we really care about informations. How do we get those things? And here is the point where the connections are made to get to the symbols. And then there is also the knowledge management. The knowledge management is mostly part of a bigger organization where you really try to keep your knowledge and not losing the knowledge if anybody of your company is leaving you. So that's the part of the knowledge. And also, of course, this part is the intellectual assets of your company, because the knowledge is on your side. Nobody can make your job. And this is your intellectual property. So if we turn this steps of knowledge into automation, we will see a similar part like maybe most of you guys know the automation pyramid, where we have different levels, beginning with the field level, the control level, the supervision level, the planning level, and the management level. This is also an overview how every automation project or application should be run. We have those 5 steps, and the field level is the basis of everything, because here is where the process or where the manufacturing is being done. Then, of course, we have the control level, which controls everything in the field level, and then we have those 3 upper levels where management, planning, and supervisory is being done. And of course, the information management part, so the first 2 parts of this pyramid are the OT level, so the operating technology, and then in the upper levels we have the IT level, the information technology level. And on those levels, this is where all of our cloud applications and data analytics applications are being run. So as you see here, the field level is really the basis of the whole automation pyramid, and in the field level is where we have our symbols, where we have our data. So as you see here, the field level is the basis for everything. So the power of automation, of knowledge, and everything is depending on what is in the field level. And here is where we have to go to get benefit, to have improvement. You can have as much knowledge as you want, but without reaching to your field level, without reaching into the field, without having the information out of your devices, you won't be able to generate any benefit, any optimization, and you will not be able to have the benefit out of digitalization. So let's make a deep dive into the NOAA No More Open Architecture, which is a module which is trying to combine all of these level uh, with a second data channel. So as we see here, the normal pyramid is really communicating from the lower level to the upper level. So there is no communication over you can't overstep one level. So it's really down to top communication. And the NOAA No More open architecture tries to get the data directly out of the field level and communicate them directly into the clouds or other applications. And this is where OT and IT are being combined and mixed. Yeah, this is the deep dive into the device level, where we have our PLC and where we will have all of our devices. So yeah, smart devices. What are smart devices? We have actors or sensors which supply us with all our process values, or which can have an impact of our process values. And those devices today are not only sensors and actors, they have many information inside of them. We can make a lot of knowledge out of them with the information they have supplied to us. But the point is, there is also often a lack of transparency of the field devices even installed in my application. In many applications I have seen, they didn't even know what kind of devices are installed or what firmware is there running, because they had a lack of transparency of the field devices. And also often process modernization and improvements from time to time increase complexity in those applications. Overall, to say, there are numbers saying that 79% of data and information inside of those smart field devices are unused, and it's also extremely difficult to access those data via existing control system. Another big issue is that over 80% of installed field devices only use 4 to 20 milliamps, so only analog technologies. Even if those devices have hard implemented, it is not being used because, yeah, 4 to 20 milliampere is an analog technology, and it works just fine for everybody. And maybe also the PLC or the DCS systems, like the control system, are only able to control those devices through 4 to 20 milliamps. So all devices that are out there have hard installed or other communication protocols. There are smart field devices out there, but they are only being used through 4 to 20 milliamperes, and through 4 to 20 milliamperes, I only can communicate process values and know any informations about diagnostics and other topics. Yeah, and this, if a device breaks down or if a device needs maintenance, allows only active maintenance. By meaning saying that active maintenance is okay. I can only react when something happens into the field, and I don't see, if I don't have any information out of the device, I can't do any predictive maintenance. So I just have to react for failures, and it's always only a thing of reaction. I only do react and never plan. So by reacting every time, I will run into long process downtimes. This is something we don't want to have. If we proceed, yeah, okay. Another way. So as I stated here, there is really it's really difficult to access data via existing control system for us. So there are solutions allowing us a second data channel, like the Namur Open Architecture. This design allows us to implement a gateway and communicate to those devices and in any communication style or whatever communication style is supported by those devices, and then get out those data into higher systems and make those data usable. A big lack of this is cybersecurity. A lot of companies have many concerns about cybersecurity because they don't want their devices or their field level being connected to the internet or to being connected to any cloud system. So they do not like it to have those things. So the easiest part of cybersecurity is only allowing data to flow out and not allowing to get data into the devices. So it won't allow you to make any changes to the devices out there. You can only read out those information, but this is really enough, because the only thing is what we want to get out of the devices is really to get out the information they supply. Let's say a usual flow meter has over 1,000 parameters inside and has a lot of different kinds of information we can use and to optimize the process in real time. There is no need to change those configuration for now. So there is no need to change those configuration for now. But if you want to make optimization, for sure we have to change a bit of configuration or change any parameters. So how is this being done? Oh yeah, another topic also. Devices are getting smarter and smarter from time to time. There are also device vendors out there that are mixing actors and sensors and putting them into one device. The devices can communicate between them, and the control system is often not being used anymore, or it's not anymore necessary anymore. So the devices make the communication between those. The control system is in the field, the power is really in the field and between those devices. This is also a trend that is being seen, and as you see here, this will be then the only way out to communicate those data, because there is no communication to upper levels over here. Let's go back where we are right now. So we still need those PLCs. So if we go to mobile plant asset management, so this is all part of plant asset management, getting out those data. In this scenario, we will need to have somebody who's out there and making those implementation that we have made, or that we would like to make after we did get the device information out of them. And those in concerns of cybersecurity, we will still have the need for maintenance guys who go out to the devices and make those improvements and those optimization to the devices. And the best method to doing it is to equip those maintenance guys with mobile tablets, and those tablets should be suited for a rough area or even for explosive areas. And if you connect those tablets to any databases, to any clouds, we can connect those clouds, those databases, again with higher levels or with another cloud applications, or with the NOAR level. Yes, and this will allow, so in those databases, we will have all device information stored there. We will have, we can save there any reports, document everything anywhere. The maintenance guys can also document every step they are making to the devices. They can save any configuration that they have made to the devices. It's really easy for them using those tablets and having all necessary informations at the same or in real time to making those changes to the devices. And of course, those systems are connected to each other and connected to higher levels where tasks are being set up, and those maintenance guys really do only do the changes to the devices. Yeah, and of course, those maintenance guys need somehow a connection to the devices. So yeah, and a big problem is also that those maintenance guys face in their application different types of communication protocols that are, or even different devices from different vendors. So there could be multiple vendor systems. And for now, the communication to the devices is being done by different types of standards, and even every device vendors has his beloved standard, so everyone is using a different one. So this makes the work for the maintenance guy really complicated if they face different vendors and different communication protocols in their daily work. We have set up some questions, and we would like you guys to answer them.
On your first question about mobile solutions for asset management, 76% of our listeners do not use mobile solutions today. 24% do.
Okay, cool.
Okay. And then with regard to multiple devices, 83% have multiple vendors, and only 17% have single vendor in their daily work routine.
Okay, perfect. Thank you very much. So yeah, this shows me that maybe you guys also face these problems that a lot of our customer has faced. Those different device vendors offer different types of communication or different standards. Like some only support FTT or the FTT DTM standards. Others only support a device description. Then there are also other device vendors that have only FDI standards. So there are a lot of different standards, and every one of those device vendors has its own, uh, not its own standard, but their preferred standard. Yeah, where I was to hook up again here. Okay, we have this data channel. This is the second data channel, which allows us the connection to the devices to get those data out of our devices. Again, with that being said, most of your devices, or almost all devices that are out there, has at least hard implemented or any one of these other protocols. So to get to those data, to get to your smart field devices, you will need to set up this second data channel, or this data channel will also work, but this is a mobile channel. A stationary channel will allow you to have the information at any time available for everybody. So this is the preferred channel you will need to implement asset management or to implement device knowledge. Most of the time, this channel won't allow us to get to those informations. Yeah, what I wanted to say is that you do not have to tear down or to update every time all your applications, your installation bases, or to buy new devices or new expensive PLCs. The most simplest way to implement planned asset management is really to put a second data channel in combination with those mobile solution. So you're always on. So in concern of cybersecurity, this would help you extremely. Okay, let's move on into asset management. So what is the main task of asset management? The main task is really to secure that the plant runs at a maximum capacity and efficiency. What is our biggest pain, is the inefficiency in maintenance, which generates long downtimes. Asset management helps us getting information out of our devices, out of the field level, and with that information we can plan and increase in efficiency, or and secure that our plant is running at a maximum capacity and efficiency. Our biggest pain is the inefficiency in maintenance. So what are the typical maintenance tasks that are being done? There is the commissioning of devices. Then there is also, of course, the configuration and parameterization of those devices. For sure, also the calibration of those devices. And of course, if any errors occur or if it's necessary, the replacement of those devices. If we go into mobile maintenance, or if we equip our maintenance guys with mobile solutions that are connected to our system via Wi-Fi, we can ensure that our maintenance guys do the commissioning the right way. They do the configuration and parameterization the right way, do the calibration and the replacement of the devices the right way. Using a tablet connected to the internet or to our internal database helps us that the maintenance guys that are out there in the field have the information they need at any time to the tablet. So even if they need any support, they have cameras on the tablet. They can use those cameras, asking questions or making photographs of those devices and sending to anybody who is a specialist and is way far from the maintenance guys can give him directly support, and having libraries or device information that are being needed. If they are not up to date, he can update them and have at every time the information and the software he needs to do his work the right way. So what is the main benefit out of asset management? It improves maintenance effectiveness by corrective and preventive maintenance. So preventive maintenance, we only can do preventive maintenance if we have access to diagnostic functions to our devices. Our devices or your devices can tell you if they are running good or not, or if they are going to run bad, or if they are not. And by using those data and those information out of those devices, we can improve the maintenance effectiveness, and we will and device replacement can be planned ahead of time, and we don't have to wait until a device breaks and only react. And also implementing standards reduces the complexity of the installed base. So if we really try to work with one standard or with one tablet and have a connection point which supports different types of standards, which supports different vendors, will help to to reduce the complexity in communicating with those devices. And of course, if we have preventive maintenance, spare parts storage can be also reduced. So we don't have to have a big storage of spare parts and wait until we need them. Using preventive maintenance, we really know, okay, hey, in the next couple of months, we need to change those and those devices, and we will buy them just in time and not having them stored for too long in time. And finally, the plant's availability is increased and maintenance-related risks are entirely managed, which helps us a lot. As I said, we need here is a connection point to our devices, which brings us to device communicators. So the tablet at all doesn't have the connection or the physical layer to our field devices. A tablet helps us, or the tablet has the connection to the internet or to the internal servers, and has also different types of software installed, and also it's a tablet is mostly like open. It's Windows based, or it can be also Android based. It can even be Apple, so iOS based. So I can install any application I want, I use or I need. And if we see into device communicators today, we have two types of device communicators. Those here on the left side, which are mostly USB modems. Those modems are working mostly with, like they can be used also with a tablet or with a computer. But those modems only mostly support just one protocol and are not really designed for a rough area, or they are not really designed for maintenance. People who go out to the plant and use them, and they are easy to lose because most of them are really small, and they had a lot of customers that told me that they are losing them on a daily basis. Then there's the other side of device communicators, which are handhelds. These are also available from different vendors. Those devices are really specific, because mostly of them are, yeah, there are pretty much only like, I will pick out this one. This is from a maybe some guys of you know that, which is from a big device or big vendor, and they're really specific for a really specific need. They support sometimes multiply protocols, but unfortunately they don't have any connection to uh, to the outer world. So they don't have wireless included, and I can't easily install other applications. So I'm really stick to the application that are installed priori here, and I can't use it for other um, for other topics or for other tasks. So I really can just communicate here with devices, and most of those devices are extremely expensive, starting in about $5,000 or even more. Yeah, and if we go back to the solution I mentioned before with the tablet and an interface, using these interfaces. Here on the left side, we see those interfaces which has only one protocol available. So I will need several of them to communicate to devices from different vendors. So this is here where softing comes in. We have here our mobiLink, which is a multi-protocol mobile interface, which has a hard master included, a foundation field bus host, and a Profibus PA master, all in a single device included. Foundation field bus and Profibus PA are optional, so you can buy them as a license and add them to the mobiLink. The communication is done via Bluetooth or via USB, and it's perfectly suited for tablets or smartphones due to battery-powered Bluetooth operation. And it supports, of course, Bluetooth. There are two types of Bluetooth standards. There is the Bluetooth Classic, the Bluetooth BLE, which supports also connection to iOS, so the connection to Apple devices. And as I mentioned, there are different types of standards communicating to the devices. The mobiLink supports really most or the major engineering tools and the standards. It supports FTT DTM. We have also a DD-based operation through the DevCom application, which is an Android and iOS-based application. And of course, we also have the FDI communication server available. And of course, it's suitable for use in hazardous areas. It has an X approval for Zone 1 and Zone 2, and also for Division 2 and Division 1. It's suitable for connection to intrinsically safe circuits, and it's suited for harsh environments because of its IP54 certification. So it can get wet, it can get oily, everything can be put on it. So yeah, some other parts about mobiLink. So we can connect to hard devices by point-to-point connection, and then connect it to tablets, to smartphones, to whatever we want. We have an Android application, and the same also for Foundation Fieldbus or Profibus PA. What tasks can we handle it? So it's a mobile fieldbus access for iCycle read and write access to all parameters of a field devices. So I can really access all parameters of the device using this handheld, and I can read and monitor process values and device status. I can perform the parameterization and configuration of field devices. If we use other tools or using commissioning tools or calibration tools together with the mobiLink, the calibration can be observed. Of course, we can run diagnostics to the devices, and we can do a condition monitoring. So a quick summary. The mobiLink again is has multiple protocols. It's easy integration. It has an easy integration with major engineering tools. It's an out-of-the-box solution, and together with those tablets, I really just connect them via Bluetooth and make a point-to-point connection to my field devices, and I'm ready to go and ready to do the device configuration, parameterization, commissioning, or calibration. Yeah, whatever job has to be done. Yeah. I would say thank you for your attention. Thank you very much for participating in this this webinar, and I hope it helped you.
Great, Scully. Thank you.
Yeah, thank you. Too.
We have some questions that came in, so let me fire them off to you, and we'll get to as many as we can within the last few minutes that we have here. All right?
Sure.
Okay. Somebody asked about OPC UA, and they say, can't you use the OPC UA protocol to communicate with devices using HART, Profibus, etc., instead of having multiple protocols in mobiLink?
Yes. The point is that the devices that are installed out there, those devices have different types of physical layer. As soon as those devices have OPC UA protocol, we could talk to them OPC UA control. But the point is that those devices doesn't support that. So the mobiLink is an access point to the devices, and that's why we need the physical layer to communicate to those devices. Using the FDI communication server, so FDI is based on OPC UA, so we have it there, but the devices that are installed do not support those kind of communication. So we have to adapt to their physical layers.
I see. Great, thank you. Another question about terminology in general. Someone asks, is the NOA NMR open architecture used in fog computing? Is this part of the fog computing concept?
To be honest, I can't answer this question right away. I will take it with me, and I will, or if you let me know who has asked this, I will contact him directly.
That'll be fine. We can do that offline. No problem.
Awesome. Perfect. Thank you.
Another question is, some companies' cyber laws don't allow any remote read-write access. Is this a solution for them, or is there some other solution?
Yeah, mobiLink would definitely be the solution because it's not a remote, and that's why mobiLink is being used, and that's why I if I go back to the slides, here, as I mentioned, there are a lot of cybersecurity concerns saying that they do not allow to write. Most of them allow us to read those data, but not to write them. And that's why we need a local representative inside of the plant and does it directly without doing any remote access to the devices. So a mobiLink or the solution combined of a tablet with the mobiLink allows you the direct access. And yeah, you're
Gotcha.
inside of the cyber laws. Yeah.
Okay. One question related to that gateway that you show there. They asked if Softing uses Moxa gateways, or do you have your own gateways for secure communications?
We do have our own gateways. We have a big portfolio of gateways, and we also allow have different types of gateways that allow us the connection to different types of protocols, and there are we have our own.
Okay. Another question with a phrase I've never heard before. How good are narrowband IoT plug-and-play devices? For example, communicating one way towards the cloud and then data can be harnessed from the cloud.
Okay. I will definitely take that question with me, and we will have a nice chat about that in private. I would say so.
Okay.
Yeah. Let's do it that way.
No problem. This person wants more clarity, and you may have answered this before, but if you allow use of a tablet in the field that supports configuration changes, but this is also connecting upstream as well, doesn't this essentially create a security issue by allowing two-way connection through the mobile device?
This tablet is being being used by a person who is allowed doing those changes. Those maintenance guys are highly trained technicians, and they're allowed to do the changes on the devices. They control what information are going to the device and what information are going to the cloud. So there is nothing such a direct connection. It allows only the connection to a cloud-based solution, allows only the maintenance guy to upload the information he thinks that has to be uploaded to the cloud. So it's really on the technician. There is still a person of the company controlling which data are going out of the field. So there shouldn't be any security concerns.
Gotcha. Okay. Another question. How long has the mobiLink device been available, and have any large companies like Shell or BASF or other signature companies approved specific use of it?
So I'm really not allowed to name all of our customers, but mobiLink is available since 2018, and yes, one of those two is already using mobiLink, and we have also a lot of big companies and also from oil and gas and from all around the world using the mobiLink. We have a lot of big customers using them.
Okay, thank you.
Yeah.
Another question is about range for wireless communications. How big is the range for the Bluetooth connection between mobiLink and the tablet?
Okay, so yeah, the tablet and the mobiLink are connected by Bluetooth, and the Bluetooth standard is 15 meters. So it's 15 meters of connection range between the mobiLink and the tablet. So going out into the field, you can connect the mobiLink to the device, and let's say if we are in in hazardous areas, the maintenance guys only have to go in, make the connection, and can leave the X area and do the do his work out from outside of this area. So up to 15 meters.
Okay. Great. And then are there any plans for, or is there the ability to extend the mobiLink connections beyond tablets to things like smart glasses or anything else that might come along?
Yeah, for sure. We also have a smartphone vendor who's also interested in the mobiLink. So as long as there is a operation system like Windows or Android running on those glasses, we can make the connection directly to them. So there's absolutely no concern. So we can do that, definitely, yes. But we need the application running on the glasses.
Excellent.